Hey everyone, welcome to our muscular system video. In these crazy times with this coronavirus, we're going to try to get through it and maybe we'll come back to school and maybe we won't. But if they want some grades, this is how we're going to do it. So each of these little videos will be about, 10 minutes or so. And then I will have a Google Doc that will accompany each little video. You will be able to open up the dock at on your phone or at your house or on your computer, and everywhere that there's something red, that's where you can just start typing your answers. So let us begin. As for the muscular system, that is, well, it's a couple of things. The muscular system, as far as you're concerned, is only the skeletal muscles. That's what are going to move your actual skeleton. But there are other types of muscle tissue, and that it would be cardiac muscle tissue or smooth muscle tissue. So we're going to talk about each of the muscle tissues today, and the rest of this presentation or the rest of this chapter will focus on the actual muscular system. Okay, so let's see. How do we move to the next slide? That one? All right, so the muscular system itself has many functions, and some of the functions you may know, and some of the functions you may have absolutely no idea. The most obvious is it allows you to move. So whenever your muscles contract, now remember, contraction is what muscles do. They do not straighten out. The straightening happens when the opposite or the antagonistic muscle contracts, which lets the opposite one relax. So it's going to provide for movement. And it's going to move the skeleton, and it's going to also move some of your internal organs with, again, smooth muscle tissue. It's going to maintain posture. This is what allows you to stand up straight, something that you take for granted, but you can do it. And babies, they haven't quite figured that out yet, and that's why if you put a young baby sitting up, well, they fall flat on their face or on their back. It's going to generate heat, and this is what is going to be most of the energy lost by your system is in the form of heat, and that's why we will overheat very quickly if we don't sweat. And, of course, to stabilize our joints so that they don't just kind of bend sideways. Obviously, many people have had joint injuries, and that's usually due to changing direction very quickly, like in a football running back or in a soccer player of any sort, or if you got hit. So those are ways that would be a possible joint disruption. But as long as that doesn't happen to you, life should be good. And again, as I told you, they have one job, and that one job is to shorten, and that happens once again when they contract. So remember that. We'll talk more about that as we go. Okay, so the types of muscles we are going to have, like I said, are going to be three. We're going to have skeletal muscles, we're going to have smooth muscles, and we're going to have cardiac muscles. So let's look. Skeletal muscles, again, are attached to your skeleton. And that's what a bulk of this is. Your smooth muscles are going to be found in your organs, things like your stomach, and things like your intestines will also line your blood vessels. You have no control of those, by the way. And finally, cardiac muscle will be found in exactly one place, and that is your heart, once again. These guys do not technically count as the muscular system, but they are types of muscle tissue, and we'll find out later that they have no voluntary control. Skeletal muscle do. All right, now this picture here is going to help you with one of the questions. So if you can see this and you can zoom in on it, life will be good. Skeletal muscles, as we said already, are attached to your skeleton, and they're going to allow you to move, which of course we've talked about already. Your cardiac muscles are only found in your heart, and your heart will beat hopefully for your entire life, or it has been beating for your entire life. And your smooth muscles are going to be found in things like your stomach and your blood vessels. Now, the key here to see is that some are going to have what is known as voluntary control, which we will talk about. That means you can control it. And others will be known as involuntary, which you have absolutely no control over. You could try to control some of these things with breathing, but you can't just tell your heart to stop beating. It just doesn't work that way. And we're going to talk a little bit about the structure of these, which is kind of this row right here, but we'll talk about each in their own spot. And the key about what is known as the speed of the contraction, and this is what's kind of cool, is your skeletal muscles can do a lot of things. They can move very, very, very slowly, and that would be a nice smooth maybe yoga move or a nice smooth dance move. Or they can move very fast, like let's say playing a 16th note on a guitar or a violin or something where you're moving your fingers very, very, very quickly. So it's kind of cool. And they are not very rhythmic, meaning that they are just going to do what they're going to do when you use them. When you get to your cardiac muscle, if you notice here, they come in one rhythmic pattern only, and that's slow. And what I mean by slow is it's a beat, something like that. Now, if it beats faster, like beat, 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 that happens because you have a greater demand for oxygen, but the general beat pattern is slow. And it is extremely rhythmic. You will hear that sometimes your heart rhythm is off. That could mean that you are in trouble. So you want to make sure that it's very, very, very rhythmic. Now, your involuntary smooth muscles are very slow. That's basically like, pushing food through. And that could take many, many, many hours to push food through as it goes through your system. So very, very, very slow. Once again, both of those are involuntary, and we'll talk more about that as we go. So skeletal muscles themselves. You will not need to memorize every single muscle, but you will need to know about 10 major groups, and we'll get into them more towards the end of these lessons. But first of all, they attach to the body skeleton, and they are what are known as multinucleated, which means that if you have one muscle cell, and they're usually long and cylindrical, they may have multiple nuclei, which they're basically the only cells you got that have that, and they can function properly that way. And one muscle cell can reach up to a foot in length, and those would primarily be in your legs, because your legs are going to be your longest muscles, especially if you're tall. And they are known as striated, and I'll show you what that means in the next picture, but they almost look like they have stripes. And most important of all, they are voluntary, which means you control them. Now, a spasm doesn't really count, but if you want to move your fingers, or you want to raise your arm, or you want to do a push-up or go running, or even speak, all of those are voluntary actions you have to think about to do. In the world of striations, this is kind of a drawing, but you can see that it almost looks like these muscles have stripes. Almost. Now, they're not really stripes, but it looks like they have stripes. And that's what the striations are. And you'll notice that they will attach to a bone. So they're attached to a bone there, they're attached to a bone there, they're attached to a bone here. And what they will do is when they contract, oh no! When they contract, they will do something like that particular muscle there. When it contracts, will raise your arm. That one right there is your bicep. That will bend your arm. So those are the jobs of those particular muscles. Now, the skeletal muscle itself is actually broken up into layers. Now, unfortunately, I really wish I could have shown you this when we talked about it in person, but it's kind of hard now because I'm here. But you're going to see this basic structure in a nerve as well as a muscle. So let's kind of start big. The muscle itself has to attach to a bone. So that's going to happen with a tendon. And again, tendons are very tough. And what will happen is that bone and that muscle will be attached once again by this tough thing called a tendon. Now, when you look at a muscle itself, and this again is very kind of hard to see at first, but a muscle is really a lot of muscle cells all working together. So believe it or not, the muscle cell or the muscle fiber is tiny in the grand scheme of things. There are many, many, many muscle cells that make up one muscle. And if you look at this and you count them, there's probably going to be, in this particular picture here, about 70 muscle cells, maybe more. You'll also notice they have a blood supply, and that's important. That's going to bring oxygen and bring away carbon dioxide. But now let's talk about the breakdown. So let's kind of start inside, and then we'll work our way out. The muscle fiber itself is surrounded. It's very hard to see, but if you look, there's what looks like a white ring around kind of a red dot. That white ring is this, and they couldn't really jam them up together, but it's called the endomysium. And what this does is it's very, 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 very thin. and it surrounds each individual muscle fiber. So let's focus on this area up here. So let's see, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I got about 15 muscle cells there. And each of those muscle cells are wrapped up by this thing called an endomysium. So those 15 together are going to make up the next wrapper, if you will. And the next wrapper is going to be called a paramecium. Now, the paramecium is represented by this thing, this wrapper that kind of holds all the muscle cells together. Now, the package deal of the paramecium and all the muscle fibers together is known as a fascicle. So if you look at that, now there are about 1, 2, 3, 4, 5, 6, 7 fascicles that you can see. Then, finally, all 7 of those fascicles that you can see are wrapped up by a very tough outer layer known as an epimecium. And that is what keeps the muscle together. So let's kind of look at the words now and what they mean. So the endomysium is very delicate. It surrounds each individual muscle fiber, which we talked about. The paramecium is going to be a little bit tougher than that, and it is going to wrap around each of those muscle fibers / endomysiums, and it's going to make a thing called a fascicle. And then the fascicles are surrounded by a tougher layer known as the epimecium. And if you kind of look here, as the epimecium kind of gets denser and smaller there, that's what forms the tendon. And the tendon, once again, is very, very, very tough. And yep, perfect on that picture. Okay, so there it is bigger. So you will have to fill this in on your first question sheet, but that, again, pretty simple stuff. Now, the tendon itself is very, very, very special. If it didn't do that, you wouldn't be able to move because your muscles are humongous and they'd get in the way of all of your bones. So the tendons have a very important job, and they're going to anchor the muscle to the bone, which we said already. And they're tough and durable, and hopefully they last your whole entire lifetime, which is amazing, we hope. And the key there is because they're so thin, they allow for the space to be conserved so that you can move at the joints. Because most muscles, let's draw that. That's your femur, let's just say, which we learned from the last chapter. Let's say that is your lower bone, your tibia, and let's say that's your fibula right there. Your muscles are going to be, let's say those are your quads, which will be on the top. And what's going to happen is the tendon's going to kind of wrap around your knee and connect to the next bone. If that tendon was not super thin, it would not be able to go around the bone. Therefore, it would get in the way, and you can forget it. So bending your leg or bending your arm would be almost impossible. So again, tendon's pretty important stuff. Smooth muscle, again, we're not going to talk too much about it here because this is more the muscular system, but I have to mention the types of cells they are. These guys are going to have no striations, hence they're going to look smooth, and that's why they're called smooth muscles. And very, very, very importantly, they are known as involuntary. Okay, no control by your brain. You cannot say, oh, stomach, don't digest today. It doesn't really work that way. So they are involuntary. And they have only one nucleus. That's it. That's a major, major, major difference. And they are not long and cylindrical. They are going to be found in sheets. That's what gives them kind of a little bit of strength. And they're not going to be connected to any bones. If you look here, this is there's one nucleus right there, and all of these muscles are kind of sort of in sheet. All these cells are sort of kind of in sheets, and they're found in your stomach. And also lining your blood vessels, which we already said. And finally, your cardiac muscle, which is our last type of muscle for this lesson, is going to be involuntary again, so no control by you, or no conscious control by you. That's more important. And now this is where things get kind of interesting. They're going to have some similarities and some differences to your skeletal muscle. They are going to be striated, so that's similar to skeletal, but they're involuntary, which is similar to smooth. Well, they're only found in your heart. Okay, that makes sense since they're cardiac. But they're going to be unique in that they're branched. They're the only muscle cells we talked about that sort of kind of look, as you can see it here, they look like they make a branch. And what's even more obnoxious is they may or may not have more than one nucleus. So you see there, that particular cell has more than one nucleus. Some do, some don't. These intercalated discs are going to be used to hold the muscle cells together. So hopefully they'll have a nice long life beating away. And let's see. I think that might be it for the old cardiac. Let's see. Nope. One nucleus per cell. Again, mostly. Some will have multiple, but most of them have only one nucleus. Okay? So that is our muscle cells and a brief introduction to the muscular system. There will be several questions that can be answered using a Google Doc. Okay? We'll pick up with video 2 soon.